Hey guys, so today I'm going to show you a different module that I've been working on over the past couple days, and this is a module that controls more of a UI aspect of menu navigation, where you can define a full menu definition with multiple nested levels in a configuration file in the JSON format, and then essentially that menu definition can be loaded into the program, and then from there you can attach to different sections or views of the menu in terms of the nested levels by a tag and an ID, which I'll talk about later, and control the feedback for each of the menu items within that view, and so on. But before I dive into the program, I think it's better to kind of show a working example of this. So I'll open up my X panel and we'll connect to the controller which is already running this program. I don't know why they don't just default to the normal port, but so here you can see I'm already connected and I've already navigated away from the root menu, but basically you would start here and you can see you've got some text, you've got a header node, you've got icons. If we navigate inside of menu item 1, that becomes the header because that's the parent menu item for this nested menu list, and then you can select different menu items there. Now to show you an example of what the config file looks like, here's the one that's currently on the controller. It's an RMC3 that's running this program. So we've got within the root menu, we've got menu item 1, menu item 2, menu item 3. So there's the 3 menu items. I'll expand menu item 1, and you can see within menu item 1 we only have leaf nodes, so essentially menu items that don't contain nested submenus. And we've got a few different properties, so I'll go ahead and explain some of these since they don't exist on all of the menu objects, and that's because some of these are optional parameters, but they do have default values. So in the case of the name, this is optional, but it has kind of a useless default value. So if you didn't provide a name, there's no big deal. You just see some template text instead. The tag is what's used to associate a specific menu item. So in this case, it would be from here to here. All of this information you can pair up with a simple Windows symbol to control all of the submenu item feedbacks and whatnot, as well as the main menu item properties. And these things would include at runtime or from the config file you can change whether a menu item is enabled or not, whether it's visible or not, and then based on the runtime feedback, if that's high or low depending on the program runtime state, you can define alternative text to show if the feedback is high. You can show an alternative icon, and that's indicated by the feedback name and feedback icon JSON keys, which are also optional, which is why I don't see them down here. And this one's just got 4 plain icons with 4 plain menu items with an icon of I. So if you go back to home, menu item 2, you can see there. And then the third one, before I go on to explain some of the next points, the third menu item contains a few nested menu structures. So within 3.1 there's nothing, but within 3.2 there's nothing as well. And within 3.3 you can see there's a submenu here. So you got 1, 2, and then 3 menu items. The last one's got a little bit more depth to it, but the first and the second one contain a list of other menu items. This one's got 4, the first one had 5, as you can see here. And if we go back one level and go into 3.3.3, you can see we can navigate within So 332 and 333.2 and 333.3 don't contain anything, but within 3.1 we've got another level of menu, and the last items don't have anything, but the first item at 1.1 or 1.1 contains another menu item with 3 items there. So this is really flexible, and it's quite powerful that you can define menu structures completely from a config file, and then all you need to do is just pair things up within your simple Windows program, and you can change things at runtime if you ever need to deviate from the config structure itself and all of its properties. As you've seen in the first menu item here, you can set whether things are enabled or not. I think I did change this one locally before I uploaded, but this one was true before. The default values for some of these other optional parameters, by the way, enable if not defined is the same as setting it to true, and same thing with visible. And the reason why I did that in particular is because if I didn't default to true, then you would have to, even though these parameters are optional, then you would have to define enable as true, visible for true for every menu item, and that kind of overcomplicates the JSON structure unnecessarily. And then the other thing is, with the icon, the default is blank. And the reason for that is being that if we didn't default to blank, then all of these would have the very first icon within the theme definition, which in this case is it would have been the exclamation mark with the surrounding triangle. And I didn't really want that. I wanted this to be truly optional so that if you don't define it, it doesn't show any icon. So the default is really just the blank icon here. And so now I can kind of show, before I dive into the feature with the slots, I can show you how the feedback and everything kind of behaves in terms of the config file. And I think a good place to start is menu item 1, since we've got some different properties among each of the items. So I've got my debugger prepared here with the SIG file. We'll have to connect. And this isn't blanked out, so I'm going to have to put this off screen here. Okay, should connect here. And it synced all my signals. And we have to find the signal associated with this first menu item. So if we go down into our, it's not the listings, it's the node one for menu item 1. See that pairs up with this config file, menu item node, because we've assigned it as a tag with menu item _1, and that matches what we've defined down here. And then again, we're just loading from slot number 1, which basically we have 2 slots defined here, and they're both loading the same configuration file. But I'll get into that a bit later, because it's a little bit more tricky to explain this stuff after the fact. So what we need is the signal for the first menu item feedback. So I'll copy this out, and we'll put this in our debugger, and we'll bring up the X panel and the config file just so we can see everything all together. So for this one, I defined a feedback name and icon. So in this case, when the feedback goes high, it'll also change the name and the icon to whatever you've defined here. If these didn't exist, then it wouldn't change the name and the icon. It would stay the same. It would stay consistent with the inactive feedback state as well. Oh, I'm not even on the right one. So if we go back home, menu item 1, now we can see here. So the active state contains the new icon with the eye, and the text also changes to append the active text in brackets at the end. And if we release this, it goes back to the original state. And So let's do menu item 2 just so I can show you. Menu item 2 feedback, because we didn't define a feedback name or icon, there's no alternative states in terms of the text or the icon, so it just turns blue and then goes back. But if we set enable, and now you can see this is an analog signal as defined by my the debugger's text color here that I programmed. And the reason for this is because I wanted 3 different states. So if we loaded from a config file which defined a certain set of properties for enable and visible and all that, and then we overridden that from the program, I needed a way, or I wanted a way, to revert back to what the config file value was. So in this case, 0D is the config value, whatever the value is, or whatever the default value is if the key isn't defined for the specific property that you're trying to set. 1 is enabled as a manual override, and 2 is disabled as a manual override, or false, I guess, true and false. So 1 is true, 2 is false. So we can see that here. So I'm setting enable for menu item 2 within this node, and I'll set it to a value of 2, which is disabled. And then if we set it to a value of 1, then that's the manual override for on or true, which for the enable property means that it's enabled. And then if we do the same for visible, the numeric values are the same things. So 0 is the config default, 2 is false, so it got rid of the second item, so you can see it skips from 1.1 to 1.3 there, and we have 1 less item in the list. If I set it back to 1, then that is a manual override of true, so it's visible. And if we set it to a value of 0, then it takes the config default, which is true because our menu item didn't disappear on us. And so the other thing is, with these list modules, which drives the smart graphics navigation and everything and all the visibility states and text feedback and all that, the way that pairs with the node module is if the node, so you can see by the current tag here, we're at menu item 1, and for this node module we're pairing it off with menu item 1. So if it's on this particular view within the menu, then this listing module, in this case it's this one, this listing module, which is driving this list right now, pairs up in memory and keeps a reference to this node module. So if I was to press any outputs here by selecting an index, which is the way I've programmed it, then that index which gets selected propagates to the items pressed outputs here. So you can see here, if I press the first item, this signal will be pulsed, and it's commented out because it doesn't have any destination, so I didn't want any warnings in this demo program. But it's menu node 2, menu item 1, pressed, logic wave pulse. So we'll clear the debugger output there, and if we press number 1, you can see that pressed output went high. But if we're not on this, if we're not on that view within the menu, then the reference to this doesn't exist. It would have been associated with a different node module. So if you press the first one, then you can see menu node 3 at menu item 1 got pressed instead of the previous menu item, node 2 menu item 1. So it's kind of like a cross point layer, all defined within SIMPL Sharp. It's all encapsulated for you so that you don't have to manage where you are in the menu, and I think this saves a lot of time in addition to being able to define things through a config file dynamically, because it's easy to change. You don't have to change any of your program, you don't have to mess with anything. If you change the structure of where the items are situated, so if you wanted to move this up or down, it doesn't affect your programming at all, as long as the tags are still relevant and everything else. So now, let's describe the functionality intended by these slots. So slots or groups, I might use those words interchangeably as I kind of demonstrate this, but it's really the same thing. So slot 1 is associated with ID 1. So when we put these numbers down in the bottom of the symbol for ID, so you can see there is ID 1, ID 1. So these are all part of the same slot or group, essentially. And they all receive the same menu definition at slot 1 for all the output information, for setting all the feedback, for pairing up with all the tags. Because I've defined one here, they all get paired up with that. So the way this controller works is it's actually the first module that gets initialized automatically in memory. So whenever this one's defined, and you only need one of these in a program, it will loop through each of these definitions and load whatever files it can into their corresponding slot. And then once that completes, it talks to the other modules in memory to tell the node modules now to go ahead and start initializing to receive the definitions that were loaded into the corresponding slot based on the ID that's defined down here. So in this case, now that this controller is done loading everything into the slots, this node module can load from slot 1 the definition defined that was loaded into memory from this file. And now that it contains a reference to that menu definition, the next node module can initialize, and once all the node modules are done, then it tells the listing modules that they're allowed to initialize. So it all happens automatically in memory. It's very scalable, and you don't really have to deal with much other than putting in the right file paths and the right IDs and the right tags. So this one's also in slot 1. So now, essentially what this does is it will start from the root for the menu definition that was loaded into slot 1, and as it navigates through, if it finds a menu node that is associated with a node that you have defined as a symbol in your Simple Windows program, it will receive all the feedback defined from the runtime triggers to each of these sections on the module for the menu items that get displayed on these outputs. So for feedback, enable, visible, and whatnot, as long as it's at the corresponding node within the menu. And then so the benefit of that is that you can have separate groups of listing and node modules, but within a specific slot you can have as many listing modules as you want and as many node modules as you want, as long as they pair up with menus that have a tag defined. So that way all the node modules within that particular slot can control all of the feedback for every listing module within the same slot. So to demonstrate that, I've defined 3 panels here. The panel at ID 3 and the panel at ID 4 are both associated with slot 1, and the panel at ID 5 is associated with slot 2, or group 2 is what I named it in the subsystem. So you can see here, if I open up the listing module, we're at ID 2. So essentially, because this is ID 2 and this node module is ID 1, anything that I set on the inputs of this node module for feedback, enable, visible, and whatnot, it doesn't affect this listing module. this listing module, because it doesn't have any other node modules at ID 2 for this specific tag, it only receives the state defined by the config file. And you can't change that at runtime unless you defined another node module with the tag menu item 1 and ID 2 to match the same slot that the listing module is in. So now that I've kind of given that a complicated explanation, we can open up two other panels here to represent the two other panels that I haven't loaded. So we've got our first one, I'll keep this in the top left, and this one's going to be number 2. So IP ID 4, and we'll go all into menu item 1 on all 3 panels, so I can demonstrate this. And then the last one we're going to put at the bottom, instance number 3. This is going to represent the third panel, which is part of slot number 2. At IP ID 5. Okay, so now if we set feedback on the node module for menu item 1, I'll copy this signal out and put it in debugger here. And remember, the first X panel and the second X panel are both part of slot 1. So this one is part of slot 2 because we've given it an ID of 2. So when I set the feedback for the first menu item within the menu item 1 node, you'll see that only the list modules in slot 1 get affected, and this one is completely separate. Now, regardless of whether the list modules are in the same group or not, every list module can navigate through the menu independently of one another. So you can see here, if I'm at navigate home, well, this one's on menu item 3, this one's at the root menu, this one's at menu item 1. The only thing that the slots do is they allow you to receive the same feedback between multiple list modules within the same slot. So I can go back into menu item 1, you'll see this has got an active feedback. Or I can go back to home and I can navigate some deeply nested level within menu item 3, and it doesn't affect the navigation on this module. So with the tag navigation, this will allow you to navigate to a specific point in the menu if you needed to. So say for instance you're doing a residential system and you had multiple rooms. Well, each panel resides in its own room, and you might want to default the panel that's in the living room to the living room menu. Well, in this case, you would have like a living room menu item with a tag associated with the living room. So if we wanted to navigate to the living room, which we'll just pretend in this case is our root menu, you just send the tag and tell it to navigate. Now we're back at the root menu. So each listing module also has a current tag output as feedbacks for what the tag is at each view within the menu. So you can see here, if we navigate to menu item 2, this will change to menu underscore item underscore 2, which coincidentally matches the same tag definition in our config file. And then because root menu is the tag for the root menu item, it'd be the same thing as basically pressing the home key. And you can see we've got feedback on our button here, and this is conveniently provided by the feedback on the module for whether or not the list module is on the root node or not. So you can see there in the current tag, which we're also displaying at the bottom that I showed earlier. And then you get feedback on whether the header item is enabled or visible or not. Feedback for the header item feedback, and then this initialized button is just visible depending on whether all the modules initialized or not. So I handle the initialized outputs together and then send that to the panel. But that's pretty much it. I'd say this is a pretty flexible module, and I'll be adding a lot more features to this hopefully over the coming weeks. But I hope it helps some of you guys if you decide to use this module in your projects.